to provide a link to our events to the audience and save it in our archive for future access too. Tim, are you in Cambridge now?
Yes.
Provide a link. That's awesome. It's great to have top scholar like yourself to share with our audience. Okay, so I'm just gonna present quickly on my part. And okay, so everyone, welcome to today's event. I'm the school director at NYC Data Science Academy. I want to give you a little bit intro about who we are and what type of events we host here. So first of all, we are a national accredited data science academy. We've been running our business training in the last 9 years. And in today's session, you can feel free to share your question through Q&A at Zoom. Also, some of you have the chat enabled, so you can also put in whatever you want to mention during the session. And our school have been in business since 2013, and we offer data science bootcamp and part-time courses. And we teach both Python and R for data analytics and machine learning. We give hands-on training with individual group project, sometimes corporate come in to sponsor projects. In our school, we offer career support for lifetime. So many of our alumni came early on, probably are getting their third, fourth jobs through our help. Globally, we have more than 2,000 alumni, and we have been rated consistently as best data science bootcamp, best online bootcamp by SwitchUp for the past several years. Okay. So we have a very soon start date for August 15 and September 26 for the data science bootcamp program. It's very suitable for people who either in grad school or are working in the field, because we have part-time offering and full-time offering. You can choose remote live, in-person, or online learning. We also launched a data analytic bootcamp about 2 years ago. So if you don't have any background in data science, that's a really good starting point. So the main difference between two programs is the machine learning program is more advanced. So there have like big data component, GCP, Amazon AWS, PyTorch, a lot of deep learning content. So the expectation for project is also higher. But typically we see people finish data analytical or transfer to machine learning when they have more technical skill. Okay, so like the setup is different for in-person remote and completely asynchronized. So you either expect to devote 9 to 6, 40 hours minimum per week for 12 weeks, or plan your own study plan on your own, but you have to deliver all the learning objective per week. Otherwise, it's very easy to fall behind and you will be put into academic probation for falling behind. So our process to assess a candidate is pretty straightforward. We have a basic application you need to fill out. We have a behavioral interview round. We also have a technical assessment round. So typically it takes at least five days to finish the application process. We have a 40 hours pre-work package. You should consider to apply ASAP in order to have enough time to finish the pre-work. And we have great alumni, over thousands of bootcamp students graduate and land great job. So those are a few examples. People work at Verizon, Etsy, TikTok, IBM. And if you have any question, feel free to reach out to us by admissions@nycdscience.com. That's pretty much my presentation. I would be happy to pass the floor to Professor Tim. Please go ahead.
Thank you. This looks like a very exciting program.
Thank you.
Okay, let me share my screen here. I'm a professor at MIT, so like a little bit about me. So before I joined MIT, I was actually a professor at Brown University, and before that, I spent some time at UC Berkeley in the AMP lab, which you might know and might not know. That's like the place where they developed Spark in the end. Also, before I joined MIT, I spent like a little bit of time on Google Brain. Mainly my research interest is either on building systems to make machine learning and data science easier, or more recently, the other way around, leverage machine learning to improve the performance of systems. In this talk, I will focus on the former, and this is like building systems to make data science and machine learning easier. And it also happens to be that we formed a company around that, Einblick, which is now commercializing some of our research results there. And we are more than happy to like show you a demo of what we are building right now and how it evolved over time. But also give all of you who are listening here free access to the platform so that you can try it out by yourself. So what is it all about and why did we start working on that? So the project itself, like really started a long time ago. Like I think the first prototype we had in like 2014, so almost 8 years ago. And it was mainly motivated by how we saw data science should be, and then compared it to the reality, how it was back then and even is today. So what we mean by that is there are a bunch of like vision videos out there which depict on how data science should look like. There's one we particularly like. So Microsoft in 2015 created this vision video here where they show on how a team of people can work together on problems using one of these like large interactive screens, make discoveries on the fly. It provides this like very interactive environment where you see results unfold. And it's just like, we believe this is actually how data science should look like. So if you take this vision and you contrast it to on how data science is today, you get a very, very different picture. Right? It's just like mainly still focused on a single person working alone, coding Python, and producing some results like very text heavy. It's not this like team environment where people actually talk about what is in the data, make discoveries together. It's more like, yeah, they're individuals like scrambling around using some very code heavy interfaces. Even if you take like the latest innovations like workflow engines and so on, the real interaction paradigm doesn't change as much. You still have like a single person working on a screen. Now, instead of writing code, they're putting boxes together and connecting them. But it still stays this like very like singular experience, like where a single person is exploring the data rather than it's this team effort. And the reason why we believe teams are so important is I think there's not a single problem solved nowadays by a single person. It's more like that anything which like actually has impact involves a team to drive it, and therefore the tools to support like problem solving should also be team oriented. So with the research project, which we back in the days what's called Northstar, we wanted to change that, and we took a very different approach of building the system behind it. So like traditionally what like many people in the systems community did, just like first they developed the system, let's say Spark, and then later on they figure out a way to make it more usable. So they put an interface as an afterthought on top of the system they helped build previously. With Northstar, we wanted to go the other way around. Let's start with the user experience, the interface, and then figure out on how we need to change the system for it to power that interface. So it's like really like put it upside down. The very early interface we created, like this was around like 2014, 15, was called Northstar. We particularly designed it to run on this like large interactive whiteboards. Like this one is the Microsoft Surface Hub. But we said like anything which is like a large touchable screen can be used for it. So for example, the Google Jamboard, Samsung Flip, and so on. And really create this like to create this experience which you just shown is like original Microsoft vision. The end result, how the interface works, combines several aspects which you currently can find in different types of tools. For example, if you look at the current data science tools available, on one hand, you have BI tools like Tableau, Looker, ThoughtSpot, there are a whole bunch of them. Their main goal is to create pretty visualizations, but they focus less so on building complex models or pipelines. So what they're really, really good at is like taking a data set and visualizing it. And normally the interface around that is designed in a way that you have the visualization in the middle, which you're modifying through a bunch of like operators on the side. Again, normally focused on a single person rather than a team experience. On the other end, you have workflow engines, which are really, really great to create this in a no-code environment, complex workflows of operations. Like, for example, you can use them to do anything from like data prep, cleaning, to like model building. And then also they have operations to visualize the data at the end. The downside, however, is that like everything is hidden in this like large workflow, which you see here, without giving you a direct feedback. So they're particularly bad in like trying to figure out what happens in between. So if you just want to quickly explore a data set and create a bunch of visualizations over it to understand what's in it, these workflow engines are not the right fit for it. So somehow we want to combine the best of workflow engines with the best of what you find currently in BI tools. And then enable these like two mesh concepts with like modern collaboration tools. And what particular comes to mind here is tools like Miro or Figma, which have this like multiplayer interactions where several people can work at the same time on a problem, normally in remote settings nowadays, or like also in like using one of these like big screens, as I showed you before. So we took this like three concepts of workflow engines, BI tools, and modern collaboration tools, and try to find a way on how we can combine them into a very intuitive interface. And that was the result of Northstar, and like where we said, like, yeah, we start with the interface, and the concept of data boards was created in that way. So what are data boards? It's a way to build complex workflows of operations, but instead of having like tiny icons as the boxes, they can contain full visualizations, even Python notebooks and other things. All that is laid on top of an infinite canvas, so you can like scroll around, zoom in, zoom out. Soon, hopefully, like also group things together to build like in itself more complex operations. And on top of it, it's all like multiplayer enabled. So you can have several people work on problems together on one of these like large canvases. So as mentioned before, originally we thought like we focus on in-person collaboration, and this was all pre-pandemic. Think about it, just like it was 2015, 2016 now, and we had this first prototype of the interface ready. Particularly with the pandemic now, we also recognize like, yeah, not everybody can afford anymore to be in the room. For a long time, it was not even possible to be physically located in the same room. So we heavily invested into remote collaboration tools as well, which we can demo you in a second. So it has this like bubble heads where several people can work again together, discuss the problem, and figure out a solution as a team. So this is the interface we were after. After we did the interface, we quickly recognized actually that in order to power that, to provide the user experience we wanted to go after, we also actually have to change the back end and also a bunch of algorithms used as part of the back end. The reason for that mainly has to do with latency requirements. So let's assume like you work on a data problem, a reasonable size data sets, let's say a terabyte, and you just want to do a certain aggregate or visualize something. These operations can easily take several seconds. Sometimes for more complex operations like automated machine learning, even minutes or hours. And now assume you are in a team meeting where you want to build quickly a model over the data, and you have to wait for like several minutes until the first result comes back. This would destroy any collaboration in the room, right? So like in the moment you have to wait too long, just like people quickly say, oh, let's take that offline and let's focus on something different here, right? In order to enable people to really in real time work on a data problem, the interface needs to stay snappy and give you very quick results. And as a result of that, the backend needs to ensure that nothing takes too long to render. In fact, it turns out that there has been even a study around that by Jeffrey here and his students at UW, which showed that even small delays of more than 500 milliseconds can have a significant impact on how much people like try data exploration and test hypotheses in a data set. So even like small delays of more than 500 milliseconds can negatively impact the way people interact with data. So we try to overcome that. And this is like where a lot of the technical innovation on the backend side comes into place. Is by like what we developed is like an approximate, a progressive approximation engine, which automatically, based on the data source, let's say data warehouse, creates samples to more quickly return results to the user, and then makes the samples bigger and bigger as the user looks at the result to give more and more accurate results over time. The reason why we designed it that way is that if you have traditional approximate query processing, so if you would approximate all the results in the platform, users tend not to have trust in them because there's always the chance that like there's an outlier, there's something else, and then suddenly your result might entirely change. And so just pure approximation of results doesn't work. Our way around that is that we first give you an approximate result, but then if you wait long enough, it eventually will converge to the final answer. That way we can guarantee that everything stays snappy, and often this like initial approximate results can already help. And then if you wait long enough, you will get the final result, and you can be certain there's no change in it. Right? So it gives you the perfect trade-off between like the two objectives we are having, accuracy as well as like snappiness. So how does it work technically? So let's assume like you connect our system to a data warehouse. What it would do is like first create a small sample of the data, give you a visualization of that, and then make the sample here visualize with this bar larger and larger in the background until it's sucked in as much data as possible into a main memory, or at the same time push down the query to the original data warehouse to get the final answer computed. So we do both, run over samples as well as push computation down into the database, often at the same time. So for example, what might happen in our system is first you get an approximate result over a sample while the database is still running the entire request over the entire data, and then at some point we update. Another big advantage of the sampling-based approach with larger and larger samples is that we can also apply the same concept over more complex operations like automated machine learning, for example. So we would do the same trick, start with a small sample, give you results back, and then make the sample larger and larger, which gives us now a fine-tuned knob around like how we can trade off latencies versus accuracy. It also works for data transformations. And now a bunch of this like clever mechanisms which you have in the back end comes into play. For example, let's assume you have a one data set with a certain size. You start to transform it, clean it, fill in missing values. So afterwards, you might create a second data set which has like some of the cleaned operations in there. And now we are very smart about how we manage the memory for these like competing concerns, given that we only have a restricted amount of memory available. So the overall effect can be quite stunning. So this is like a simulation of like on how a simple filter condition with a visualization after would work over just a 30 gigabytes data set. So in both cases here, left and right, you see on the left side, we could try to do this like conditional like visualization based on a subset of the data, so which requires to scan all the data and just filter out a certain year. Here we assume that the data of 30 gigabytes is stored on S3, so we don't have it fully loaded yet. What you saw on the left is that the system was immediately able to give you an approximate answer, which you see at the bottom, in less than 400 milliseconds. And then in 24 seconds, the visualization doesn't fundamentally change anymore, meaning no of the bars change like the importance to each other. Whereas the right side, what you see here is if you would run the same computation in a non-progressive way, so assume what you have right now, and the first result you would get is only after like 6 minutes and something. Here on the left side, there's an assumption built in here. You see even that the final result is a little bit faster than just scanning all the data. This has to do with the fact that we did like a very quick small sample upfront calculation, which gives you a total benefit in the end. So why should you care about that in the end? So what I told you, you have a different user experience. It's more team-oriented. There's a progressive approximation engine behind it to make sure that everything stays snappy. But why does it matter for you? The answer for that is a productivity increase. So why you should really care about this technology is the fact that it actually helps you to make discoveries faster and get more quickly to your solution, like building a model or like finding an insight or explain something in the data compared to other tools. I'm not just saying that, we actually tried to quantify that. So this was, again, part of the research effort we had around that. So we compared Northstar, or in this case, the commercial version, which is called Einblick, against Python notebooks, against like another visual no-code environment. Think of it as like Alteryx, K9, and so on. And then we recruited actual data scientists with the requirement that they know how to code Python. Right? So like we really looked for people who know how to solve something in Python. And we gave them different tasks. For example, one had to solve customer churn, like do certain numbers of tasks with that. In Einblick, employee retention, maybe with another no-code tool, and predictive healthcare in Python. And then the next person had to do customer churn with Python and so on. So you get the idea. We mingled it around that, like each task was done by different tools, by different people, so that we get a good coverage. Each task has a time limit of 1 hour. So like if you do customer churn, and at most you could spend 1 hour to go through the entire task list, and we just measured how far you got. So the end results of the study is as follows. Like the question is, how many tasks were they able to achieve in 1 hour? And we found that with Northstar and now the commercial version Einblick, they got pretty close to finishing everything, 96%. Whereas like with the other data science workflow tool, the number were like 68%, and Python notebook actually took the longest because it required writing quite a bit of code for it, even though we gave them the full access to the internet, so everybody could just like Google and get the code snippets they really needed. The other interesting factor is just like that they are like different types of increases per task. For example, we found that for pattern mining, we have like a significant benefit over other data science workflow tools. But in overall, depending on the task, we get like a factor of 2 to 3x advantage on how many capabilities the data scientists had to actually analyze the data. Most importantly, though, we reduced the total time of like creating the insight or the model, whatever the particular task was. So on average, we saw like speed ups of like 1.5 to 2x, depending of the task, compared to the other platforms. So overall, that's a pretty good result. As I mentioned, like this was a pure research project, essentially until like 2019. And it got to a stage that people ask us if they can play around with it. And we gave it out and did like test deployments at different companies. And eventually, like the asks were like more around like, can you integrate LDAP? Can you give us like certain security like measurements and controls and so on, rather than it really that the people we were deploying Northstar with were asking for like new research techniques. So that was the point when we decided to actually move it into a company so that we can continue to support the people we are working with, but hopefully also expand the numbers of people who want to try it out and play around with it. So we are very proud of that. We are already work with like several large companies together, Covestro, Dell, Samsung, Vertica, just to mention a few. And this list is like continuing. So I hope that the people here on the call also give it a try, which is actually quite easy to do. You can just go to einblick.ai and just sign up. There's like nothing you have to pay up front. You can just play around with it, upload your data, or use one of the existing data sets and just get started. So I think this is a good point, at least to take a short break. For the remaining time, my suggestion would be that we first show you a demo of now the commercial version of what we are building. And then if there's enough time left, I'm also really happy to talk a little bit more about what we are currently doing in like for research around how to make data science more accessible to a broader range of users. So I will quickly pause here if there are any questions, happy to answer them. Otherwise, my colleague Benedetto here will take over and give a demo of Einblick. So it looks good. I think, like, let me see in the chat if there's anything. Yeah, the old name was Northstar, the new name is Einblick. That was an easy question. Okay, Benedetto, take it away.
Can you guys hear me and see my screen?
Yep.
All right, perfect. So right now I'm just connected to my account at app.einblick.ai for the folks on the line. If you connect to the same address, this is just the idea of my workspace. You can essentially create a new account on Einblick. Today I'm going to talk about a use case that was around sales and marketing promotion for a large car manufacturer. And so you can see that I already uploaded a data set to the canvas. And like this workspace is one of the many canvases that you can have to the on Einblick. So this data set is nothing else than a CSV file. I can drag out that data set and visualize it as a table. But again, you can connect multiple data sources to your canvases. You can use them at the same time. It doesn't really change anything. They can be tables that are related to each other that you may connect using the join. Okay, can be completely disconnected. Doesn't really matter. One thing that I want to point out is that you can upload a CSV file. Probably is the easiest way of analyzing data, but you can also connect different data sources by building connectors to other data sources like BigQuery, Databricks, MySQL, and so on and so forth. For this use case in particular, I'm going to focus on a simple question that would be why some people accepted or not my marketing promotion. So I'm kind of play the role of a marketing analyst or like a data scientist that is working along the side of a marketing person. So you can see here in this table, and I have my columns, my rows, and as Tim was pointing out, this is like an unbounded 2D canvas. I can zoom in, zoom out, move things around, and then I can take a look to my data pretty fast. I can just scroll horizontally or vertically, and particularly this attribute accepted. It's interesting to me because I want to know how many people from the last month accepted or not my promotion. So I can just take the column name, drag it over the canvas, and I will the system will automatically generate a bar chart to the best guess the platform does of the chart that I want to have, right? So if I over on top this bar, I get a 39.14% acceptance rate. Of course, the remaining one of people that are not accepted. And I kind of want to show you how easy it is to bring in your data, build a table, have a first visualization, and quite literally just build a model in a matter of seconds. So I can provide this. The platform has a workflow style approach, as Tim was pointing out. So we have our input data that it's here. You can see this blue data set, this data set here that goes through this table. And then I can give the output of this table as an input of the trained data. And then as a target variable, I'm going to use accepted. And as a features, I'm going to select all the attributes in this column, in this table. Then I can select the different metrics that I have. So it makes really, really, really easy to build a model like in a few seconds. And then the runtime for now, 30 seconds. We don't have much time, so I'm just going to build a quick model here. So the AutoML will take care of all the different steps necessary to build a model. So it will be pre-processing, which means scaling, hot encoding, label encoding, and then we'll do model class, model selection, hyperparameter tuning, and so on and so forth. So I don't need to do anything about that. The result is this kind of chart. On the y-axis, we have the accuracy of the best models found so far. On the x-axis, the runtime. If you remember, I put 30 seconds, so it should stop. Yeah, it's just stop right now. So it's gonna stop when the last model started before the 30 seconds actually is done. So we're gonna complete that model for you. And then here you can see that in 30 seconds, 43 pipelines were evaluated. Just think about doing this manually. It's quite amazing to be able to test so many different models in such a short time. But also what it's nice is that the model that you build are not like black boxes. Like this is the model that you get and that's it. You can use the explainer that comes with every pipeline. So for example, I got this model, 100% accurate in 2.4 seconds, and then inspect what's going on. So as a data scientist, I know that you're super suspicious about this model being 100% accurate. We all know that usually there's some issues when our models are that good. So we can inspect the different metrics. Even if we choose accuracy, we still get a nice overview of all the different metrics. We are our validation strategy, 7,000 rows used for training, 3,000 rows used for testing. So the system is going to do a train test split for us. Steps, label encoding, imputation, normalization, as gradient boosting. So far, there's nothing dramatically weird, right? But the nice thing that I like to use when I use Einblick or when I use it with our users is to drag out the explainer, right? This is a pretty powerful tool that comes out of the box that tells us which are the most important factors. And so the top two factors are applied online, applied at dealership. So you guys that are tuning in right now might not be familiar with this data set, but the point is that if someone applied online, applied at dealership, they're already accepted implicitly, right? Our promotion. So, like a tool like this kind of shows you how you can detect like information leakage in this case and kind of debug what's going on in your model. And the really cool feature about the platform is that you can go back and forth between predictive analytics and descriptive analytics as we did before, because if you want to communicate what this means to maybe a less technical user that doesn't know what feature important is, then you can use this to go back to our data set and say, okay, what this means is that if I drag out the accepted attributes over the canvas, and then I use my applied online and apply the dealership visualizations, I can put them nicely outlined like this, two at the top and one at the bottom. What I can do is to use those visualizations to filter this bottom one. So I'm going to select the people that are applied online, and I want to see the breakdown of how many people accepted of the people that applied online. And some of you might already know the answer, right? All of them. And same thing here. I want to know the people that also apply at a dealership. And there's also is an empty data frame. So what this is indicating is that either you applied online or you applied the dealership. You cannot do both. And then both of those two people are what essentially compose the people that accepted. There's also a more interesting way of looking at this, that it's brushing. So if you click on the link, you can brush your selections. And so you can clearly see that brush one is the people that apply to the dealership. Brush two is the people that applied online. And those folks are just here, right? So that's why the model is so good, right? There's information leakage. This plot clearly shows what we're talking about. There's no people that applied online or dealership that did not accept. So what we need to do is to go back to our AutoML, deselect those two attributes. Of course, we need to also remove dealer ID, but that doesn't have like a big impact as information leakage. And now we should able to see like a much more reasonable model here. The x-axis still have the runtime. The model now, the first one that returned after 2.7 seconds, has an accuracy of 86.8%. So still good, but of course not at the same level as the ones that we saw before. Hopefully by the 30 seconds, we're gonna have another model. If you're wondering why there are more pipelines evaluated than the ones that are on the canvas, well, the reason is that it might be that the pipelines that are tested are not better than the ones that have been found at the beginning, right? So we just return pipelines that are better, essentially. So I can take a look to the versions with explainer and drag it over the canvas. And this tells me now the features that are most important. I can use the executor to get kind of the probabilities of which are the customers that the system thinks are the most likely one. So we have our original table plus 3 additional columns, the actual prediction, the probability of being false and probability of being true. Of course, this is sum up to 1. I can, again, go back and forth between descriptive and predictive analytics. And using the explainer, I can also go prescriptive. I can use Shapley values. And essentially Shapley values, what they allow me to do is to get a quite good understanding why the model make that prediction. So in this case, the prediction of the model was true. So the customer is going to accept. And the explanation of the model is telling me is this person at 51 years old, got an incentive of $600. And then you can see like the impact of each one of those attributes. So the least important attribute is that the lease length was 36 months. So this is in terms of kind of high level going back and forth between ingesting the data by import it here from the left-hand side, do some visualization, building a model, and go really back and forth between descriptive and predictive analytic. Also, you go in prescriptive using the explainer. But one of the cool features about Ironblake is that you can also ingest code and in your canvas. So what I can do is to kind of mix and match code and no code functionalities. For example, I can bring in the promotion list transaction dataset in this Python script operator, and I can use any of the libraries that I love from like the Python ecosystem, right? I can write here all the libraries that I want to use. By default, pandas is already imported. So I can do a new column, new call is equal to 1. This is really simple operation that we can do. And then if I drag out this table here, essentially you need to return the data frame. This df. And then if we scroll at the end, we have this constant, and we can write anything that we want here, right? So if we want to have range len df, and then have like a counter, this would be a simple counter as an extra column, we can do that. We can essentially do whatever we think makes sense for our analysis, and just add it to our canvas, and then go back to depending on what we're trying to do, low code or no code at all type of visualizations. Last thing that I want to cover and then open for more question is just to show you guys how the canvas can be used as an interactive whiteboard, right? So here I have a share option, which I can use to share this workspace with anyone in my organization. So I can invite other folks in my team. For example, I can invite Peter on our team, and then they will be able to join the canvas together with me. I'm going to show this with myself. So you can see that I'm logging in. It's the same account. I'm logging with the same account, but I hope that you get the idea of how this would look like. Essentially, you can, as in a Google Doc document, you can log into the canvas, and then you can see that my other session just logged in. So my name is here, exactly as happens on Google Docs. And so I can track myself on the other side, right? So whatever I do, if you remember the location right now in this canvas, right? If I start moving around in this other one, my other session will follow me essentially. So you can see the change on both sides. And of course, this creates a lot of opportunity for collaboration. So what we worked on are those video bubbles. So you can see right now, I just activate video bubbles on my side, and I can have a conversation. This is what happened. This is exactly what happens every time that we talk with our clients, right? We join multiple people in a canvas. We talk about data. We talk about data science problems. There might be data scientists. There might be domain experts. What happens is that you transition from having an abstract conversation about data to actually be able to jump around in a canvas and have analysis at the same time with multiple people in the tool. Maybe the last thing that I want to cover is that there are many other functionalities in the tool. You can see here on the, let me close this other tab here. On the left-hand side of the canvas, you have quite a bit of option, not only for the data set and for different data sources, but really for the operators that are available. So right now we just use the limited section, like to make some visualization, to build a model, but we have so many other functionalities. For example, one of the most used features is the key drive analysis operator. And again, this is, for example, a data mining technique that we developed that essentially is able to tell you what are the differences between two groups of people. So for example, I can say, what are the differences between the people that accept my promotions and the people that do not accept? So of course, I'm going to run this in the wrong way just to make you guys understand what's going on with the key driver analysis. So right now, the input data frames are exactly the same. So not surprisingly, it's not going to find any difference, right? 64.5% on the test data set and the same on the control one. And not surprising, this is the same data set. There's not much difference. But then we can use the same techniques that I showed you before in terms of visual queries, right? Like you don't need to write a SQL query. You can just click here and filter this test data set, just click false and connect to the control data set. And then rerun this operator. And what this will do is to find differences between those two groups. So really powerful, especially if we're in the initial stage of the analysis process. For example, you remember that applied online a dealership and applied online was problematic for AutoML. KDA is able to detect this immediately. Acceptable equal true is kind of straightforward because that's the way we filter the input data. So it's telling you the people that accepted are 100% of the test data set and 0% of the control one. And the difference between those two numbers, 100%. And same thing for applied online, applied at dealership. And then you start getting more interesting insight. For example, the age buckets, seems that folks between 39 and 54 represent 42% of this data set and just 25% of the right one. And you can just scroll this list, and if you're confused by those numbers, maybe because it's the first time to use this operator, you can just click on top of those numbers, and we provide you an automatically generated kind of slide that tells you what's going on and what those numbers mean and how they're related to each other. I think this is pretty much it for the demo, kind of connected to Tim's presentation. I want to open the stage for questions that folks might have.
I see you have free version. Can we use the free version to do everything you mentioned today?
Yes. You can just go on our website. So if you go on ironblick.ai, Give me 1 second. Yeah, so you can just click here, use Iamblic free, and then you can just sign up. And so that there's a premium version where you have access to 5 canvas, and that would be, all that you need to get started and explore Iamblic.
Got it. And what's the story of the name of your company?
I think Tim is better suited to talk about the name.
Sure. So actually on the team, there are many German-speaking people, researchers originally. And so Iamblic is a German name, and it's a very clever name. Nobody, unfortunately, gets. So if you write it as one word, like is it shown on the website and so on, it means inside. If you write it as 2 words, like ein Blick, it means one view.
Ah, interesting.
So it's a clever naming scheme, but yeah, obviously almost nobody gets it unless you you come from Germany or Switzerland, one of those places, Austria.
And I think when I share your workshop with the audience, a few of them told me they know your old version, the Northstar. So is that the one you mentioned, Star, like 7, 8 years ago?
That's right. So this Iamblic is totally based on the research prototype, which was called back then Northstar. So it's this came out of a research project, and of course a lot of things have changed since then. Like the entire interface looks like a little bit different now. They are much more functionality built in, but the core basis of it was done at Brown and MIT.
Got it. And so there are a lot of product going IPO soon, similar to what you're doing. Dataiku, Data Robot, Domino Lab. So how would you position your product and offering? It's already very crowded workspace.
It's a very, very, very competitive space. That's true. Probably the biggest differentiator is clearly the team collaboration, capabilities Iamblic has compared to anybody else, so that several people can work together actually to do discoveries as a team. Whereas all other platforms we are aware of, they are mainly focused still on a single developer. The second big difference is that the entire engine is based on this progressive approximation engine I mentioned before. So if you ever worked with a larger data set, you will very quickly notice that you get significantly benefits if you use Iamblic, because you're never blocked and have to wait for results. The last one is actually more subtle. It's the interface, how it's designed and how certain functionality are exposed to you, just enables much faster prototyping and making discoveries. So this is something which is it's hard to see unless you try it out. But in the moment you try it out, you will see for example, exploring a data set together with the approximation engine goes so much faster than some of the other tools out there. And the reason for that is that it combines this aspect of visualizations, this workflows into one single interface. So those are really the key differentiators, I would say. Benedetto, you want to add anything to it? You're muted.
Probably it's just a combination of collaboration and progressive engine too. It's I think it's a unique feature, just combining those two things, because if you think about it, you cannot really collaborate on a data science project on a large data set in real time, right? If you're not approximating, nobody wants to wait 6 minutes as Tim showed before just to get a bar chart. So I think combining those two to me is it's a meta feature that it kind of distinguishes the platform a lot from other competitors.
Got it. And how big is the client base now since you launched?
So we have 2 different type of clients and users. On one side, we have our SaaS offering that we actually open up at the beginning of the year, right? So it's kind of young, and so far we have more than 2,000 users that created an account on Iamblic. And in terms of the larger enterprise and more traditional type of customer, we have more than 10 of them.
Got it. Okay. And Tim mentioned you was at Berkeley when Spark was born, right? So I recall they have a famous benchmark test compared to Hadoop. When Spark first came out, they said it's 100 times faster than Hadoop. So I think you can do a really good proof of concept using like Bitcoin data, like more than 500 gigabyte data. Most people wouldn't be able to process at all effectively. So if you have any benchmark similar to what Spark used to have to completely beat Hadoop system, that would be very impressive.
Yeah.
Also, I know you work in Brown chemistry department have a lot of data, like more than 1 terabyte visualization data on the compound component. So your tool will be perfect to make a POC for like scientific computing examples.
That are like all excellent suggestions. So we started to do that with like, so we have a paper on the effectiveness of IMDEC compared to other platforms, and I showed some of the results early on, which like we didn't show it in the sense of like when does it fail. We tried to pick a data size which is doable for all platforms and just went after the speed of discovery. But I think you have an excellent point. What we could also do in addition is just say like pick a really large data sets and show on how everybody else fails or is like so slow. Maybe we should add that to our to-do list.
Yeah, I can send you the link to those 2 data sets, the Bitcoin and the Brown University research data. One is 500 gigabyte, one is more than 1 terabyte. You will make a really, really impressive example.
Yeah, that's a very good point.
Okay, any other questions, suggestions? Cool, it's very excited to see Professor entering this competitive world and really offering something very unique. I appreciate the opportunity to listen to your product and offering.
Thank you. Thanks for having us again. It was a pleasure.
Thank you.
Okay, bye guys.